I've got bad news for Porsche Taycan owners. Their electric car technology is evolving faster than you can say Porsche Taycan Turbo S Cross Turismo. That is to say, the latest generation of Taycan is here, and the lineup is better in basically every single way. You might think that because it has more battery capacity, that it's heavier. Nope, it's lighter. You might think that because it has way more power, that range will suffer. Nope, it's actually more efficient. You might think that because it holds a lap record at the Nürburgring and Laguna Seca, that Tesla stands would stop reminding you that for the price of a well-equipped Taycan Turbo S, you could buy a Tesla Model S Plaid and a performance Cybertruck and a Model Y Performance and still have money left over. But they absolutely will not. And okay, real talk, that's kind of actually a valid point. Regardless, the peak of the EV performance sedan has three contenders: the Model S Plaid, the Lucid Air Sapphire, and Porsche's latest addition to the mix, and the track king, the Taycan Turbo GT. And with the newest generation of the Taycan, Porsche has really leveled up their EV game, with a concerted effort towards pushing the boundaries that's refreshing to see from a legacy automaker. So put your glasses on and focus, because we're going in deep on what will likely be the nerdiest video you've ever watched on Porsche Taycan, as we focus on four key elements of the new model: the battery, the charging experience, the powertrain, and finally the suspension, as Porsche's new Active Ride provides an extraordinary level of chassis control. Starting off with the battery, capacity is up thanks to a revised chemistry and pouch-style battery cell. It's an NMC 811 battery, meaning the cathode material split is 80% nickel, 10% manganese, and 10% cobalt. Gross energy capacity is 105 kilowatt hours, up from 93.4 kilowatt hours on the last gen, with a usable capacity of 97 kilowatt hours, significantly greater than the previous 83.7. So with capacity up over 12%, you'd expect the battery to be larger and heavier, but it exists in the exact same footprint and actually weighs 9 kilograms less. So what impact does the new battery have on range? Overall, range is up about 34% for the new Taycan, based on the worldwide light vehicle test procedure. The largest contributing factor to this is the larger battery. The next largest factor is whole vehicle optimization, like decreased weight, improved aerodynamics, and better rolling resistance. Drivetrain efficiency is also improved. And finally, an improved drive and regen strategy makes up the remainder. But range is not the only perk of the larger battery. It also means you can deliver more power. The previous Taycan's battery could deliver 860 amps of current during launch control. The new battery can deliver 1100 amps, which, paired with an 800 volt architecture, is good for 815 kilowatts in the most powerful Taycan, the Turbo GT. That's a jump of 255 kilowatts over the most powerful Taycan from the previous generation, nearly 1100 horsepower versus about 750 horsepower. Quite the leap. But the energy doesn't just leave the battery quicker, it also goes back in much quicker as well, which brings us to charging. There's two ways for energy to go back in the battery: regenerative braking, where you use the car's kinetic energy to recharge the battery by slowing it down with the electric motors, and of course, plugging the car into an outlet. Both are now faster. From a regen perspective, at high speeds, if you hit the brake pedal, the battery can take in up to 400 kilowatts of recuperation power. That's way up from 290 kilowatts previously. Porsche brake pedals blend the motor regen with the friction brakes. But with the new battery, you can press that brake pedal even harder without tipping into the mechanical brakes. Regen alone can allow for up to 0.46 Gs of slowing power, up from 0.39 Gs previously. There's a compromise at work here. Personally, I find that the brake pedal, because it's blending regen and mechanical brakes, doesn't quite feel as good versus the alternative strategy, such as what Tesla does. For Tesla, regen is accomplished by lifting off the throttle, known as one-pedal driving. This enables the brake pedal to be dedicated purely for the mechanical brakes, and as a result, the feel is very consistent. Porsche doesn't do this, but on the flip side, they can decelerate at higher rates using regen alone, and this means in a scenario where you're braking hard, the Porsche will be more efficient, putting more energy back into the battery. Technically, you could do this on the Tesla as well, but it would mean anytime you fully lift off the accelerator pedal, you'd have really heavy braking. Part of what makes the drivability so nice is that you can fully lift coming to a stoplight and the regen is quite calm, with no fancy footwork required. Hard braking should be rare, so the compromise of limiting one pedal's driving max regen rate tends to be worthwhile for daily driving. Wait a sec, what's going on with my footwear? Oh, glad you asked. Shout out to today's sponsor, TuxMat, that provides floor mats with year-round protection for any scenario. They cover a much greater area than the factory floor mats, are of course waterproof, and personally, I'm a big fan of the quick snap tabs and Velcro clips that ensure they stay precisely in place, locking in with your factory trim. So whether you're hiking, rock climbing, snowshoeing, skiing, scuba diving, you name it, your floors are ready for adventure, and you don't have to worry about the mess. My floors are looking great, thanks TuxMat. You can find a link to floor mats that perfectly fit your vehicle in the video description. Okay, so we were talking about braking, and while the latest Taycan has more powerful regen, it also offers faster fast charging, up to 320 kilowatts at the pump versus 270 kilowatts from the previous gen. In ideal conditions, that translates to a 10 to 80% fast charge in just 18 minutes, whereas previously it took 21.5 minutes. And so you're thinking 3 minutes, big deal, but keep in mind it's also a larger battery pack. So from 10 to 80% means you're putting in more energy, another 9 or so kilowatt hours in less time. And perhaps you missed when I said in ideal conditions. The real world is messy. You end up at a charger when it's cold outside, and suddenly all the numbers are way off, and charging can take much longer. Not the case with the new Taycan, which has vastly improved the breadth of conditions that it can accept fast charging. The old battery needed to be at a balmy 35 degrees Celsius to charge at its maximum rate. That's now just 15 degrees Celsius for the new battery, a drop of 20 degrees according to my calculator. This has really important implications, which can be better understood through two different scenarios. First, let's say a new Porsche Taycan and an old Porsche Taycan both show up at a fast charger with 10% battery left, and both have their batteries at 15 degrees Celsius. While the new Taycan will immediately start charging at the maximum possible rate, the old Taycan will start fast charging but at a limited rate, while also working to increase the battery temperature so that it can accept a faster charge. The result is the new Taycan will be at 80% charge in just 18 minutes, while the old Taycan will take twice as long, 37 minutes, to hit 80%. So the obvious advantage here is real-world faster charging. But there's another sneaky advantage baked into this. For our second scenario, let's say a new Taycan and an old Taycan are on their way to a fast charger, perhaps on a road trip, and they're both 30 minutes out from the charger. To ensure the car will charge at the maximum rate, both cars start preheating their batteries to the ideal temperature. The old Taycan needs to heat the battery all the way to 35 degrees C, so this requires a lot of energy, depleting the battery even further to a lower state of charge when it arrives at the charger. The new Taycan only needs to preheat the battery to 15 degrees C, so under plenty of driving scenarios, it won't have to preheat the battery at all. And if it does, it's a much smaller amount, meaning less energy is used, so you arrive at the charger with a higher battery percentage. Or you have more range, and simply keep on driving to the next charger. And if you're nerdy enough to still be listening, I have great news, as it gets even better. Not only does it have a much lower battery temperature for peak charging, but it can also heat up the battery twice as fast as the last gen. The onboard heat pump and high voltage heater are capable of dumping 17 kilowatts of heat into the battery pack, up from just 7 kilowatts previously. This is incredible for winter driving conditions, as it means the Taycan will have no trouble getting the battery pack up to temp quickly for fast charging, while the old Taycan has way less power and needs to bring the battery up to a much higher temperature. And in case you were wondering, if it's super hot outside, the new battery pack can also fast charge at higher temperatures as well, and it has more cooling power versus the last Taycan, 12 kilowatts up from 9 kilowatts. All in a battery that weighs less. It is better in every single way. Sorry, old Taycan owners. Let the disappointment continue, because the new powertrain is also much improved. Every single Taycan variant, and I'm told there are 14, is faster and more powerful. The base Taycan is up 80 horsepower. The Turbo S is up 187 horsepower. And yeah, there's a new Turbo GT, which is up over 340 horsepower from the previous Turbo S. The Turbo GT is hitting 0 to 100 kilometers per hour in 2.2 seconds, or 0 to 60 miles per hour in just 2.1 seconds. And that's a Porsche 2.1 seconds. None of that rollout nonsense. It will actually do it. And this is all done with just two motors, with only a single motor in the rear, which is an interesting discussion. Porsche looked into possibly using two motors in the rear, much like the Tesla Plaid or Lucid Sapphire, but ultimately it would have required a huge packaging rework. That's code for expensive. But also there wouldn't be much benefit in terms of launching acceleration. That's because Porsche opts for a different strategy, and unlike the Tesla and Lucid, has a 2-speed transmission in the rear. With revised gearing on the Turbo GT, first gear allows for boatloads of wheel torque for a great launch off the line, while second gear now reaches a higher top speed, 305 kilometers per hour or 190 miles per hour. Both the front and rear are permanent magnet motors, with a new, more powerful motor in the rear. In the Turbo S, you have a 600 amp inverter in the front and a 600 amp inverter in the rear. This means you can send about equal power to each motor, though in the real world, the torque bias is always going to favor the rear. For the Turbo GT, there's a new silicon carbide inverter in the rear with 50% more output, now peaking at 900 amps. So you have 1100 amps you can deliver from the battery, which can be split front to rear, with the front accepting a max of 600 amps and the rear accepting a max of 900 amps. If you have a hard time digesting these numbers, the math conveniently works out where each amp roughly translates to 1 horsepower, so potentially peaking at about 900 horsepower at the rear motor. That's a huge number, but it's also for a brief moment, as peak power during a launch is only available for 2 seconds. Okay, back up a second. How did I get that 900 horsepower number? Well, if the car has 815 kilowatts of peak power and the battery delivers a maximum of 1100 amps, 815,000 watts divided by 1100 amps gives you 740 volts. Looking at the rear inverter, 900 amps times 740 volts equals 666 kilowatts, or yeah, as I'd mentioned, about 900 horsepower. All of this power in a vehicle engineered to handle a track means insanely fast lap times, and the Turbo GT now holds the title of fastest electric series production car at both Laguna Seca and the Nürburgring. And it's the fastest four-door around the ring period, which includes vehicles with combustion engines. Part of the key to that success? Of course, a brilliant suspension. The Taycan now offers Porsche's Active Ride, a complete level up in terms of capability and vehicle dynamics. Personally, I kinda like to think of it as suspension by wire, in that much like steer by wire and brake by wire, you now have complete control of how the suspension behaves for any given situation, at any given moment, in real time. The chassis engineers aren't simply picking a spring rate and a damping rate, then dusting their hands and calling it a day. You can tune this suspension for absolutely anything. The simplest way of thinking about it, at every corner you have a damper with a piston inside, which is controlling the height of the shock at that corner. Each damper has its own electric motor and pump, which is powered directly from the 800-volt battery. So at every wheel, you can control the exact ride height by using hydraulic pressure to move the damper's piston up or down. It can do so quickly and with tremendous force, about 1 metric ton of force at any corner. In theory, the dampers could take over the job of the springs as well, though it would require continuous energy to do so. As a result, Active Ride is paired with an air suspension, which allows for holding the car up at any chosen ride height. But the dampers do eliminate anti-roll bars, as this job can be completely covered with the new setup. The implications are absolutely wild. You can eliminate pitch and dive, whether launching or braking. You can keep the car completely flat during hard cornering. You can manipulate tire loading to maximize the work done by the inside tires during cornering. But it gets even more wild. If you were to have 2 motors at the rear, of course, you'd have very precise control over the torque at each wheel. But Porsche only uses 1 motor, so they compensate with the use of an electromechanical limited slip differential, ensuring the wheel with more grip gets more torque. However, it can also use the Active Ride suspension to manipulate the force at each wheel, pushing downward on a tire that loses grip to very briefly increase its load, so it can thus receive more torque, balancing it with the other side. It is suspension-based torque distribution. Or say you're going over a jump, Active ride can also force the tires to make contact with the ground, assuming, it's a small jump. The famous Flansgarten section of the Nürburgring is a great example, which is often a downhill jump if you're traveling fast enough, but here the Porsche actually maintains contact with the ground by pushing down the tires. So while there are performance advantages of the setup, there's also massive comfort improvements. For example, you can have the car lean into the corner rather than roll out, or tilt the car forward as you accelerate, or lean the car back as you brake. And for modest bumps, what's absolutely wild to see is that they can be effectively eliminated, as the suspension very precisely counteracts the forces it sees at the wheels. Also, since this is a low-to-the-ground vehicle, it can quickly pop the ride height up 55mm upon opening the door, to make ingress and egress easier, lowering back down once the door is closed. If you're a current Porsche Taycan owner, I'm sorry to say, but you're going to have to upgrade. The new Taycan is such a leap forward in every metric. And if you made it to the end of this video, bless your scholarly devotion, as your curiosity has allowed this channel to persist, and I remain so grateful. If you have any questions or comments, feel free to leave them below. Thanks for watching.